Good morning everyone. My name is Meena, working as an assistant professor in the department of CSE AIML, MLR Institute of Technology. So today I am going to explain about supervised learning technique in machine learning. So this is an overview of our presentation. So the first one is what is supervised learning technique and what are the steps involved in supervised learning technique and how it works and what are the types of supervised learning technique and the types are classification and regression. So coming to supervised learning technique. So it is a type of machine learning technique. So in this supervised learning technique, the machines are trained using a labeled data set. So what is labeled data set? So whatever the data set we are using to train our system. So in that data set, the data points and the features, the data points and the features of that data points are having a particular name or the label. So that is what labeled data set. So in the data set, the data points which are having, so those data points are already labeled or named itself. So this type of data set is called as labeled data set, and this labeled data set is using for training of your system. So this type of learning is called as supervised learning technique. And on this basis of that labeled data, the machine will predict the output for the new data or the unseen data. So here the labeled data means what? Some input is already mapped or tagged with the correct output name. So what is the meaning of this mapping or the tagging? So here for example in input we are giving a data set, the data point is cat. So the input we are giving a data set and the label of that input is cat. So now whenever you are giving an unseen data point to the system, it will predict the output. It will predict the output with the name of this cat. Either yes, it is a cat or no, it is not a cat. So this is what supervised learning technique. It means that here the input data is already mapped with the correct output name. So next, so in supervised learning technique, the data provided to the machines work as a supervisor. So why the supervised learning name is means, so here we are using a labeled data set. So this labeled means we are giving a particular name to the data points. So that is the reason it is called as the data which you are providing to system, which you are providing to train to the system. So this is working as a supervisor to the system. So that teaches the machines to predict the correct output for the future purposes. So what is the main goal of supervised learning algorithm or the technique is to find the mapping function, to map the input variable x to y. Okay. So now the aim of the supervised learning technique is to find the mapping function to map the input variable to the output variable correctly. So this is what. So input variable is cat here and the output variable will also be cat only. Either it is yes or no. So next, the real world applications of supervised learning technique are risk assessment, image classification, fraud detection and spam filtering, etc. So next, what are the steps involved in supervised learning technique? So first we need to collect the data from various resources and we need to make it as a data set. So the thing is, first you have to determine which type of training data set it is. Then means which type of training data set. Either it is a text files or it is a images or it is a audio or it is a video. Right? So next. So based on the type of the data set, for example, if it is an image type of data set, the problem is to solve this image type of problems. Then you need to collect or gather that training data set which is of labeled. So now you need to collect the multiple images from various resources and you need to label those images. Or already you have gathered the data points which are labeled. Okay. So the next step is, now we have a data set. See, we have a data set. Now you need to split this data set into two types. The first one is training set and the next one is test set. Okay. So the data set you are using to train your system is splitted into two types. The first one is training data set and the second one is test data set. So this training data set is used to train your system, train your computer system, and this test data set is used to test your computer system or the machine learning model whether that model is working properly or not. So this is what the purpose of testing data set and training data set. Usually we are splitting the data set into training data set, and here the huge amount of data set. For example, if you are having 100 data points in my data set, so I am going to take 70 to 80% of the data points for training set only. So here we are taking 70 to 80% of the data points or the data set for training data set for training purpose, and the remaining data points, that is 20 to 30%, will be using for test data set. So here we are training the machine learning model with huge amount of data, and we are testing whether that model is working properly or not with the less amount of test data. So this is what if we give a training to the system or the machine learning model with a huge amount of data set, then it will mostly give accurate outputs for unseen data points. So next, determine the input features of the training data set. So whatever the data set you are using for training of your machine learning model, the first step in supervised learning or the important step in supervised learning is find out or extract the features of the data points in your data set. So to find out or to extract the features from the training data set, we should have enough knowledge so that the model can accurately predict the output. Okay. So next, determine the suitable algorithm for the model. For example, you are using image type of data or you are using audio type of data. So type of the problem, based on the type of the problem, you need to select algorithm, machine learning algorithm. So now, based on the type of this problem, you need to select or you need to choose algorithm to work properly. So the most important point or the step is again determine the suitable algorithm for the model. And next, after selecting a suitable algorithm to solve this real world application, then execute that algorithm on the training set. Okay, so now you have chosen algorithm and you have a training data set. Now execute this algorithm on your training data set. Then, so it means that the algorithm or the machine learning model is trained by using this training data set. Then you need to test your model performance. You need to test your model performance by applying a test set. Okay, so now for training data set, definitely the model is being trained. Then whether this model is working properly or not, whether this model is giving accurate output or not. So to check this thing, you need to use test data set to check whether the model is working properly or not. So next, evaluate the accuracy of the model. Okay, evaluate the accuracy of the model by providing the test set. Okay, so now you are giving a test set, means for example you are using 70 data points to train your system. Yes, the training is completed. Now you need to check whether that system is working properly or not, whether the model is working properly or not. Now the remaining 20 data points or the 30 data points are there. No, so you need to use these data points. You need to ask your model by giving these data points. Then it will predict the output for this. It will predict the output for this test data set. Okay. So now, if the model predicts the correct output, okay. So if the model is predicting the correct output for this test data set, it means that our model is correct or our model is accurate. Okay, so next, how supervised learning works. So in supervised learning, models are trained using a labeled data set, as already we discussed. So where the model learns about each type of data, because already the label is there for our data set. Now the model is going to be learn about each type of the data. Then once the training process is completed, the model is tested on the basis of test data. So now, after completion of training, and testing of a model, you have to give a new data or the unseen data to your model to predict the output. So whether it is predicting a correct output means then your model is correct. So here see how supervised learning works. So this is a labeled data set. See, this is my data set. So here the labels for my data points are here. See these, for example, if I'm having 6 edges, the label is hexagon. If I'm having 4 edges or the 4 sides, the label is square. If a data point is having 3 sides, the label is triangle. So based on the features of the data points, the labels are defined. Now this data set and with these labels we are giving to training of our system, training of our model. So now I am using a labeled data set to train my model. Now after completion of this training, the model is ready to predict the output for the unseen data, right? So before going to do that, you need to test your model whether the model is working properly or not. So how will you test the model? We have already splitted our data set like 70 and 20 ratio, right? So we are using a less amount of test data to test or to check whether a model is working properly or not, or whether the training has been completed properly or not. Now I am giving the test data without any labels, right? I am giving this data point and I am giving this data point as a test data to predict the output for my this test data. Now the model is predicting, so the data point which is having 4 sides as square and the data point which is having 3 sides, it is predicting it as triangle. So already the name is giving as an output, and here also the name is giving as an output for this particular data point. Here this is my training set, and already we have labeled for my training set. Then I am giving my test set without any name, without label. Now my model is predicting this test data with square and triangle. So already here means f of x to y means the input name, the input label is mapping with the output variable. So this is what the main goal of supervised learning technique. Next, the types of supervised learning technique. So supervised learning technique can further divided into 2 types. The first one is classification and the second one is regression. So in classification we have a defined labels, and for regression we don't have any predefined labels. So coming to classification. So classification is a supervised learning technique. Classification algorithm is a supervised learning technique. So this is used to identify the category of a new observation. So what is this new observation here? So the data point which is new to the model is called as new observation, or the unseen data to the model, right? So the classification algorithm is used to identify the category of the new data point on the basis of training data. So in classification, a program learns from a given data set, yes, and then classification algorithm is classifying a new data point into number of classes or groups. Here the number of classes are only 2. Okay, so here the output variables for classification are either yes or no, male or female, true or false, cat or dog, this or that, like that. Means it is just classifying between only 2 output variables. So classification algorithms are used to classify your unseen data point into 2 output variables only, either this or that, yes or no, male or female, or true or false, like that. So classes can be called as targets. Okay, so what is class here? So here these classes, so this is what the class, right? This is what the class of your unseen data point. So this class is also called as target variables, or the labels of your data point, or the categories of your data point. So you can call it as output variable, right? You can call it as output variable, right? So classification algorithms are used when the output variable is categorical. Okay, so these classification algorithms are used when the output variable is categorical. Okay, so the output variable is categorical means which needs to categorized. Then the main goal of this classification algorithm is to identify the category of a given data set. The first thing, okay, so whatever the data set you are using to train your model, from that data set, the main goal is to identify the category of the data set, and these algorithms are mainly used to predict the output for the categorical type of data. So what is this categorical type of data? Which defines the category of the data. Okay, categorical data means which defines only the category of that particular data. So example like name, color. Okay, so this is what a category of the data. So which is not able to measured, is called as categorical data. Next, the real-time applications of classification algorithm. So we can use this classification algorithms in email spam detection and speech recognition, whether that speech or whether that voice is belongs to that person or not. Identification of cancer tumor cells means is that person or is that patient is having a cancer or not, means the output is yes or no. And drug classification and biometric identification. So for all these real world applications, all these real time applications are having output variable as only yes or no, right? So here we are using classification algorithms to predict the categorical output variable. So this is what the main goal of classification algorithm. So what are the algorithms you are going to use to solve these type of problems? Okay, what are the algorithms you are going to use to solve these type of problems? So the classification algorithms as of now are support vector machine, navy Bayes classifier, decision trees, random forest classifiers, and k nearest neighbor classifier. We can call it as KNN, and logistic regression. So the algorithms which are used to solve the classification problems or the classification type of data points. So support vector machines, navy Bayes classifier, decision trees, random forest classifier, k nearest neighbors classifier. You can call it as KNN classifier, and the last one is logistic regression. So coming to the next type of supervised learning technique, that is regression. So regression is a supervised learning technique which is used to predict the continuous values by modeling the relationship between input features and the output features. So here the input features are independent values in the data set, and the output features are the target values or the dependent variables in the data set. So by using the statistical methods or the statistical operations, you are going to predict the output for this regression type of problems. So this regression can be utilized to assess the strength of the relationship between your variables. So what are the variables here? Dependent and independent variables. Okay, so this regression can be utilized to assess the strength of the relationship between your dependent variables and independent variables, and for modeling the future relationship between them. So it is not only assessing the present relationship and it is also used for future relationship between the dependent and independent variables. So regression analysis help us to understand how the value of dependent variable is changing corresponding to the independent variable in the data set. So here, for example, in my data set, data set is regarding experience of a person and salary. Okay, so here experience is input and salary is output, right? So now this salary is depending on the experience, right? So here experience is not depending on the salary, but the salary is depending on the experience. So here experience is independent value, and salary is dependent value, dependent variable in the data set. So I'm using this type of data set to train my model, right? So here it is help us to understand how the value of dependent variable is changing corresponding to the independent variable, right? So the salary is changing based on the experience of a person or the experience of an employee. So this is what regression analysis works to predict the output for the unseen data for these type of problems. So let's discuss with an example. So the relationship between variables in the regression can be explained using this diagram. So here we are predicting a salary of an employee on the basis of the years of experience. Okay, so here this is what experience and this is what salary. So for example, if a person is having 2 years of experience, he is getting around 40,000 or up and down 40,000. When the person is having 4 years of experience, it is nearby 50,000. So depends on the experience, So this is what X, right? So this is called as input. So the output, which means that salary variable in my data set. So this is what Y and this is output variable. So depends on the experience, the salary is changing, right? So now if we represent this experience and salary data points on my graph, it is taking a linear line or a straight line between your data points. So to represent this straight line, the formula is y equals to mx plus c. Okay, regression analysis help us to understand a linear relationship between your input variables and output variables. Okay, so this is what the linear line between your input and output variable. So to represent this linear line, the formula is y equals to mx plus c, right? So here m is a slope of this linear line and c is a linear coefficient for this straight line, right? So here regression analysis is to find out the relationship. Okay, so relationship, either it is linear or non-linear. So for this example, here we are finding a linear relationship between your input variables and output variables. So coming to the real world applications of regression: prediction of rain using temperature and other factors. Next, determining the market trends and prediction of road accidents due to rash driving, and salary forecasting, right? So already we discussed earlier. Next, real estate prediction and weather prediction. So these are the applications, real-time applications where we are using regression algorithms, to predict the output. So what are the algorithms, right? So we are using regression algorithms to predict the output for these real-time applications. Then what are the algorithms? What are the regression algorithms? So these are the regression algorithms which are used to solve the regression problems. The first one is simple linear regression, multiple linear regression, polynomial regression, ridge regression, lasso regression. So these are completely used for regression problems, right? So next, support vector regression, decision tree, random forest regression and logistic regression, right? So this support vector, decision tree, random forest, logistic, these four are used for solving classification problems as well as regression problems, right? So these four are used for classification and regression based on the type of the problem. Thank you.